Boolean values and expressions are important, but we need more than just those to enable the programs we write to make decisions. We need a way in our code to look at a Boolean value and do one thing if the value is true, and do something else if it is false. In JavaScript, we have conditional statements that allow us to do exactly that. The first conditional statement we can use is the if statement. The if statement allows us to put a Boolean value or expression inside a pair of parentheses following the word if. Then we can follow the parentheses by a pair of curly braces. Any code we place in between the opening and closing curly brace will be executed only if the expression in the parentheses evaluates to true. Let's take a look at an example. If I have a variable, we'll call first name, set that equal to Sam. Now I can create an if statement. So if followed by parentheses. And then we can put any type of Boolean value or expression inside these parentheses. So let's say if first name is equal to Sam, which we know it is, then we follow that with curly braces, and anything we put in between this opening and this closing curly brace right here, any code we put in here, will execute if first name is equal to Sam. So we can go ahead and say console.log hello Sam. Save that. Open this in our browser. We can see hello Sam. If we come back and change this, let's say same instead of Sam, refresh this, we get nothing. Because this was false, everything between the opening and closing curly brace here was skipped. It doesn't run. So if it's true, it all executes in between these two braces. If it's false, if the Boolean expression evaluates the false, then whatever's in between these two curly braces is skipped over completely. Sometimes we have something else we want to happen if the Boolean expression is false, instead of just skipping over it entirely. JavaScript provides us with an else statement that does just that. We can place an else statement right after the closing curly brace of an if statement. Then, after the word else, we put another pair of curly braces. Any code we place in between these braces will be executed only if the Boolean expression inside the if statement evaluates to false. That means the first block of code following the if will not execute, but the next block of code following the else will execute. So for example, we've got this if statement right here. We can say else, so if the name doesn't equal Sam, what do we want to do? Well, let's go ahead and say console.log hello. Actually, we'll change that to hey plus whatever the name is. So if it's Sam, we're going to say hello. If it's anyone else, we're going to say hey. Change to Tim. And refresh that. So we've got hey Tim. Change it back to Sam. We've got hello Sam. In these examples, we only have two paths that could happen. The path for true and another path for false. However, sometimes we may have multiple different paths that can happen depending on the value of something. For example, you may go to the store and buy a single gallon of milk if the price of the milk is less than $3. And you may even buy 2 gallons if the price is less than $2 per gallon. But if the price is greater than $3, you may buy none altogether. There are 3 different options in this decision. To accomplish this, we can use an else if statement. Else if statements can follow an if statement and can contain another set of parentheses with an additional Boolean expression to evaluate. If the expression is false, then it won't run. If it is true, then the following code block will run. This may seem identical to an if statement, but there is one very important difference. The Boolean expression in the else if statement only gets evaluated if the Boolean expression in the preceding if statement evaluates to false. This makes using an if followed by an else if more efficient than using multiple if statements for the same decision flow, because all of the if statements would be evaluated. So let's take a look at that milk example and see what that would look like in code. Let's say we have cost of milk. We'll set that to 2 to start. Now we said if the cost of milk is greater than, we said if it's less than $3, we would buy something, right? So let's start with 2. If it's less than 2, then we will buy 2. Else if the cost of milk is less than 3, I'm going to go ahead and log out. We will buy only 1 gallon. If it's not less than 3, then it's way too expensive. So that's what we'll say. Else so we have the if statement here, the else if, and we can put as many else ifs as we want. And then finally we have the else statement. So since the cost of milk is 2, let's see what happens. We will buy only 1 gallon of milk because 2 is not less than 2. If we made it $1.99, come back and refresh this, we will buy 2 gallons. If we made it 3, we will buy 0 gallons of milk. Now the reason I put the 3 after the 2 is because in using the less than, if I would have put 3 here first, $1.99 would be less than 3, so this would run and the rest of these would just get skipped. So since I was going by less than, I put the lowest one first and then worked my way up to the most expensive. If we have a logical decision flow that has many paths, we can use as many else if statements as we want, with a single else statement at the very end that defines the default code to execute if all the previous Boolean expressions in the if and else if statements evaluate to false. There is also another programming construct we can use to create logical paths with multiple options in a very similar fashion. This construct is called a switch statement and is used to evaluate a variable and then provide multiple different code blocks that could be executed based on the value of the variable. So an example that we could have would be if we have a grade, not numeric, a alphabetic grade. So A, B, C, D, or F. And we want to see what the grade range is for that. We could do something like this. Let's say var grade equals C. Now we want to print out the ranges for any letter grade. So we could say switch, and then in parentheses, we're going to evaluate a variable. So we're running a switch on our grade. And then we have, instead of a bunch of different else if statements, we have the case, which says if it's C, do this. If it's A, do this. So we don't use ifs, we use case. So if the case is A, then we're going to go ahead and say console.log. The range will be 90 to 100. Then we add a break statement. We do case B, console.log, B ranges from 80 to 89. and then break, and we'll go to C here. Okay, C. The range here is 70 to 79. And then lastly, we do default. And default is for if none of these are, if it's not A, B, or C, if it's anything else, what do you want to happen? So we'll just say anything other than those is going to range from 0 to 69. Now the reason we have a break here is because the break is telling JavaScript, if I am an A, if grade equals A, run whatever code here, and we can put as many lines as we want. It doesn't just have to be one line. After we execute these, break out of the case statement. Otherwise, if we leave the break here, it will just drop down and execute the next statement. So let's take a look at what happens here if we run this. If we refresh this, we have our milk stuff happening there, 70 to 79, because it was a C. Let's make it an A, save it, refresh, 90 to 100. Now let's look at what happens if we remove this break statement. It prints out, let's clear this. It prints out 90 to 100 and 80 to 89 because it kept going. It just dropped through to the next code to execute here. The break is saying as soon as we hit the case that matches, we want to exit out of that. So something else to be to consider when we're working with conditionals and logical paths is that when we have multiple conditions in any logical flow, it's possible to nest them. So we could do something like this. Let's say var A equals 5, var B equals 6. So we could say if A equals B, and then inside this if statement we could say if B equals 6, console.log, say A is 5 and B is 6. So save this and run. Save this. I'm gonna refresh this. Let's see what we got going here. Oh, sorry, not A equals B. A equals 5. Come back here, refresh. We've got A equals 5 and B equals 6 because it was true. It's both true. It wasn't true before because A did not equal B. So that's all true. This statement will work, but it's written poorly because, and it should be flattened. So flattening is the process of taking the if statements and combining them using the logical AND operator. So instead of this, we would say if A equals 5 and B equals 6, then console.log A is 5 and B is 6. So if we run this, we'll see two of them printed out because it does the same thing. And this does the exact same thing and makes the code much cleaner. Now, that's not to say that nested if statements are never okay. They are okay when you have a diverging path based on the nested condition. What that means is that if the first condition is true, you will do something. But what you do depends on if the second condition is true or not. So for example, let's take this one. We're going to say if A is equal to 5, we're going to, we know we're going to do something. But we'll say if B is not equal to 6, we're just going to console.log out A is 5, but B is not 6. Okay. So this is a diverging path right here. We've got if A equals 5, we're going to do something, one or the other down here. But depending on what B equals, that would change. Remember to always flatten nested if statements if there is nothing else inside the outer if statement, if it's just the inner if. So if I just have this, and this is all my code needs to do, I should always flatten those.